Okay, so up until this point, we've done inductive reasoning. Who can remind me what inductive reasoning is? Conclusions based on what? Observations, patterns.
Wait, what's the question?
I'm waiting. I don't know if you guys even know since everyone's talking over me. So I'll wait. So up until today, everything we've done has been on patterns, observations, nothing factual. We're switching gears today. Deductive reasoning is the opposite. It's based on facts, rules, definitions, properties. So these things are proven true, or we have a significant reason to believe them because it's based on something factual. Deductive reasoning. So our job on these next two situations is to decide if our conclusion is based on inductive reasoning or deductive reasoning. So it says every time Kate has worn her favorite socks to a softball game, she has gotten at least one hit. Kate is wearing her favorite socks to a game tonight, so she concludes that she will get at least one hit. What would that be?
It's not factual. It's inductive.
Is that facts or not?
No.
Well, it's not false, but
Inductive.
Inductive. That's inductive reasoning. We'd like to believe superstition is real, right? But it's really just an observation or a pattern. All right, our next one. If John is late making his car insurance payment, he will be charged a late fee of $50. John's payment is late this month, so he concludes he will be charged a late fee of $50. Deductive, right? That's a rule. If you're late on your payment, there's a penalty. Deductive. You guys see the difference? Okay. So now with deductive reasoning, we have two laws. Okay. The first one is law of detachment. Law of detachment. And law of detachment says if you're given a conditional statement, that's just an if-then statement. If the hypothesis is true, then the conclusion is true. And make sure you get down this symbolic map, okay? So we're told our conditional P implies Q. Then it says our first part is true, our hypothesis is true, therefore our conclusion is true. That's what that says. And this will make sense once you guys see a few examples, okay? So we're going to use the law of detachment to give a valid conclusion. If not possible, write no valid conclusion. If Micah goes to the beach, she will wear sunscreen. Micah is wearing sunscreen. Can we make a conclusion? That's what you want to say, but here, let's break this one down. What is P? What's our hypothesis of our first conditional statement?
She goes to the beach.
Yep. You guys label that and put P right there? P. Then what's our Q?
She will wear sunscreen.
She will wear sunscreen. Q. Now, what part gets repeated right here?
Q.
Q. What part did I want repeated? What did I want to be true? P. So is this, can we make a valid conclusion based on? It would be inductive, but since we're not worried about that, it would be no valid conclusion. No valid conclusion. And a way to think about it is there another reason why she's wearing sunscreen? What if she's at a baseball game? What if she has a tennis match? What if she just cares about wrinkles and she just wears sunscreen every day? You know, that's a thing. So no valid conclusion. Okay, let's try another one. If a student turns in a permission slip, then they can go on a field trip. Felipe turned in his permission slip. Can we make a conclusion?
Valid.
Valid, but what's our conclusion? Felipe can go on the field trip. Okay, you guys try those next two on your own. Try the next two.
It's just not valid.
You still feel it because it's not valid.
It's valid or invalid. If it helps you to think of a counterexample for why it's not valid, that's fine. And if you're a little confused, look at the symbolic form. Is it following P implies Q? Telling you P is Q, and Q is true. I'll tell you one's valid and one's invalid. Okay, on the first one, if you are 18 years old, then you can register to vote. Olivia is not 18 years old. What's our conclusion? No valid. And if you thought then she can't vote, that's a good idea. However, what if she's 19? Can she vote? If she's 62, can she vote? You don't only have to be 18 to vote. You just have to be what then 18? Over 18 or older, right? So that's why it's no valid conclusion. Okay, and the next one, if the sum of the measures of two angles is 90 degrees, then they are complementary. The measure of angle J is 58 degrees, and the measure of angle K is 32. What can we conclude?
Valid.
Yep, so if it's valid, what's our conclusion? So you want to write that. J and K are complementary. That's what you want to write. That's your conclusion, that they are complementary. Does law of detachment kind of make sense? So now we're going to switch gears and talk about law of syllogism. Yeah, it's a fun word. Okay, so law of syllogism allows you to draw a conclusion from two or more conditional statements. Your conclusion from your first statement becomes the hypothesis of your second statement. We'll actually do a fun project with this next week when we only have our 2 days of school that you guys will, I think, enjoy.
Only 2 days of school next week?
Yeah, Monday, Tuesday.
For what?
And then we have Wednesday, Thursday, Friday off.
What's it for?
Teachers convention.
Let's go.
Yep. So we'll have a nice fun week next week. So symbolically, we're going to have a statement P implies Q, and then you're going to be told Q implies R. So therefore, we can conclude P implies R.
What's those? Yeah, where's that?
Oh, that means therefore. If any of you go into like upper math in college, you'll use that symbol a lot. Therefore. Was that not on the last screen? Oh, it must have got erased. There should have been 3 dots in the last one too. The more you know. Okay, are we ready to try law of syllogism? Okay, let's see if we can have a valid conclusion. So again, always refer back to this symbolic map, okay? So if it is Saturday, then Jake has a baseball tournament. If Jake has a baseball tournament, then he will need to pack his lunch. Can we make a conclusion off that?
No. Because you don't know if it's Saturday.
Oh, that's a thought. Okay. Let's go back and label P, Q, and R, okay? What would be P? Yep. You guys label that on yours? P. What's Q? Yep, then Jake has a baseball tournament. Okay, what did we label if Jake has a baseball tournament as?
That's cute.
Q. And then what would R be? Then he will need to pack his lunch as R. So did it follow the right form? P implies Q. Q implies R. So what's my final statement?
If it's Saturday, you need to pack lunch.
Right. If it is Saturday, then Jake needs to pack his lunch. It followed the right form. You guys see that? P implies Q. Q implies R. So we can kind of cut out the middle. So if it is Saturday, then Jake will need to pack his lunch. Okay, let's try another one. If a number is divisible by 12, then it is divisible by 6. If a number is divisible by 6, then it's divisible by 3. Is there a valid conclusion we can make?
Yeah.
Does it follow the right form?
Yeah.
So what is our conclusion?
If the number is divisible by 12.
Perfect. If a number is divisible by 12, then it's divisible by 3. Okay, you guys try the next two. Try the next two. And if it helps you to label your P, Q, and R, do that. You'll make way less mistakes.
Get the not right.
Yeah, one's not right. One of them's not right. If it's not right, you just write no valid conclusion. Alright, folks, anyone want to share what you thought on the first one? Anyone feeling brave? On this first one? There is a valid conclusion. What is it on this one? Yep. Right? P, Q, Q, R. Alright, what about the second one? Did you guys hear Silas? Because I hardly did. What about the second one? No valid conclusion. Why?
Because
Yeah, not. That's why. Right, so it's saying that. All right. Now we're given the situation, folks, and we have to decide if we can draw a valid conclusion using either law. All right. So it says, given if you are 16 years old, then you can apply for a driver's license. Nate is 16 years old. Can we make a conclusion from that?
Nate is 16.
Yeah, he can apply for what? His driver's license. Okay, now though we need to decide, folks, is what law did we use? Detachment or syllogism? Yeah. And maybe you guys want to label that. Here's P, there's Q. P is true, so Q is true. You guys try the last one. Again, maybe label P and Q. And maybe there's an R.
Possibilities. Is one of them no valid?
This one is valid. This one uses law of syllogism. So figure out your P, Q, and R.
But it has to be valid.
This one, it doesn't have to, but this one is valid. This one is a valid situation. Anyone want to share what you wrote? Yeah, Julia.
If an organism is a parasite, then it harms its host.
Good job. Law of syllogism. Q got repeated in there, so law of syllogism says we can just kind of cancel it out.